Hey guys, welcome back. So we're gonna finish up part one. This is questions 13 through 24. So I also noticed in the last video that it's difficult to see the screen on the TI-84 Plus C. So for now, I'm gonna use the TI-83. Very similar, except for a few quick things. Like in the 84, you can put the fractions in. The 83, you can't. So that is a big one. Also, putting your stat diagnostics on for the TI-84, you can just press mode, go all the way down to stat diagnostics and click on. Whereas on the 83, you gotta press second 0 and find the catalog and go to diagnostics on and hit enter and make sure it's on. So, but for now, we're gonna use the 83 so you can use the screen. And if there's any of those questions coming up, I'll let you know. So 13 says the height of a ball Doreen tossed into the air can be modeled by the function h of x equals negative 4.9x squared plus 6x plus 5, where x is the time elapsed in seconds and h of x is the height in meters. The number 5 in the function represents, well, the number 5 in this function for question 13 is going to represent the initial height of the ball, because in quadratic equations your constant is going to be your height. So that's your constant, just the plain number. So that's initial height of the ball. And if you didn't know that, you can go to the graphing calculator and let me just clear that out. Y equals, clear that one out. So you type in negative 4.9 x squared plus 6x plus 5. Press second graph to get your XY chart. And initial height would mean when your time is at 0, okay? So you're not really tossing the ball yet, it's still in your hands, and it's 5 feet above the ground. So that's your initial height right there at 0, so it'll be 5. All right? Next one, 14. Says the function f of x equals 2x squared plus 6x minus 12 has a domain consisting of the integers from negative 2 to 1 inclusive. Which set represents the corresponding range values for f of x? Alright, so I see another quadratic equation that I can type in my calculator. So that's what I'm going to do. We got 2x squared plus 6x minus 12, second graph, and there's my table, and they want to go from negative 2 to 1 only. So at negative 2 I'm at negative 16, and negative 1 I'm at negative 16, 0 I'm at negative 12, and 1 I'm at negative 4. So those are the numbers I want. And if you look at choice 2, we have negative 16, negative 12, negative 4. So that would be my answer. 15. Which equation has the same solution as x squared plus 8x minus 33 equals 0? Alright, so right off the bat, this is going to be, well, there's a few ways you can do it. And we can actually go ahead and solve it by using that trick that we know, where we have the constant move over here. So we can have x squared plus 8x equals 33. And we can complete the square. So this is a completing the square problem by taking our b, putting it over 2, and squaring it. So this is our b. So we're going to have 8 over 2 squared, or just 4 squared, which we know is 16. Okay. If you don't, you can put it in the calculator. So now I can write this as x squared plus 8x plus 16 equals, and what I do to one side, if I add 16 to one side, I got to do it to the other side. 33 plus 16. If I were to factor this, double parentheses. 33 plus 16 is going to be 49. So right off the bat, I know I could cross out these choices. So we're going to have signs are the same. They're both pluses. X is in here. And then factors of 16 that add to be 8 are 4 and 4. Since I have two of them, the x plus 4s, I could write this as x plus 4 squared equals 49. And that is going to be choice number 1. Now, what if you didn't know completing the square? Well, let's prove that number 1's the answer using FOIL. So what is x plus 4 times x plus 4? Okay, x plus 4 times x plus 4. We just proved to ourselves that it's going to be, well, let's do FOIL. We'll do it over here real fast, right next to it. I know it's going to be a little bit small. So go ahead, and we all know that equals 49. So we're going to distribute x times x times 4. So we have x squared plus 4x. And 4 times x is another 4x. 4 times 4 is 16. Combine the two middle terms. We have x squared plus 8x plus 16 equals the 49. And then if we want to get a set equal to 0 to look like this, you gotta subtract 49 on both sides, and you'll have your x squared plus 8x. 16 minus 49 is minus 33, and that equals 0, so it's choice 1. So if you didn't know completing the square, you could do it that way as well. So let's move on. I like sometimes showing you two ways you can do it. Number 16 says the table below shows the weights in Liam's pumpkins LW and Patricia's pumpkins PW over a 4-week period where W represents the number of weeks. Liam's pumpkin grows at a constant rate and Patricia's pumpkin grows at a weekly rate at approximately 52%. So 52% as a decimal is 0.52, and that essentially means you're multiplying 0.52 each time. So 2.5 times 0.52 is going to give you 3.8, and 3.8 times another 0.52 is going to give you the 5.8, and so on. Okay? At the constant rate here, looks like you are adding 3.1 each time. So this is your multiplying. This one you're adding. 3.1, okay, another 3.1, another 3.1, and so on. Alright, so then, assuming the pumpkins continue to grow at these rates through week 13, when comparing the weights of both Liam's and Patricia's pumpkins in week 10 and week 13, which statement is true? So let's find out to get to week, well, we got to find out all the weeks, 10 through 13, right? So we'll go 10, 11, 12, 13. They didn't really leave you too much room, did they? So if we add 3.1, let's just do that one real fast here. We'll do Liam's. So we have, there you can see it, 11.7 plus 3.1. So the next one is going to be at 14.8. So I'll write that down. 14.8. Then we're going to add another 3.1. So now we're at 17.9. Do it again. Now we're at 21. And one more time will give us 24.1. Okay, now this guy, we got to multiply by 0.52 each time. So we're going to do 8.8 times 0.52. So, I'm sorry. You're multiplying by 52%, and then you got to add it onto the original one. Or the trick would be 1.52, because it does it in one stop. So 8.8 times 1.52 So we're at 13.376. Do it again. 1.52. We're at 20.33152. Do it again. Okay, now we're at 30.9039104. And then the last one, we are now at 32.5. I'm just going to round 32.51. Okay? So now, if you look at the choices, which one's going to make sense here? Let's take them one at a time here. So it says Liam's pumpkin will weigh more in week 10 and week 13. Well, it does weigh more in 10, but week 13, no, we got Patricia there beating him. So Patricia's pumpkin will weigh more in week 10 and week 13. Well, no, we just said that, well, Liam's does, but not that one. Liam's pumpkin will weigh more in week 10, so 14.8, and Patricia's pumpkin will weigh more in week 13. Well, that's true. And so far, well, that was probably going to be our answer. It says make sure Patricia's pumpkin will weigh more in week 10. Well, no, it doesn't. So we know right off the bat that is not the answer. So that's 16. Moving on. It says the function f of x is graphed below. The domain of this function is. So domain is your x's. So if I go to my x's, I'm at -1. And then we got a solid dot there, so I know I'm going to have a line underneath the inequality. And it's going to go on forever this way. Okay, it goes on forever this way. Even though it's going up like that, it's still moving to the right. Might be at a slower rate, but it's going to do it forever. So that's going to be when x is greater than or equal to -1, choice 4. So remember, domain is your x. Range, they asked for the range, that's going to be your y. 18. Which pair of equations would have -1, 2 as a solution? Well, the way I solve this one is I'm going to go ahead and plug in -1 for x and 2 for y for this guy, for number 18. And the one that's going to work is going to be choice 3. And let me just prove it to you. Okay. So for this one, I should say, does 2 equal a -1 squared minus 3 times -1 minus 2? And if you plug it in your calculator, we have -1 squared minus 3 times -1 minus 2, and enter. Lo and behold, is 2. So 2 does equal 2. So far, so good. Now this guy, does 2 equal 4 times -1 plus 6? So again, you could plug this part in the calculator, or I'm just going to do this part in my head here. 4 times -1 is -4. -4 plus 6 is +2. So these are the ones that work. The other ones won't work. Okay. 19 says which function could be used to represent the sequence 8, 20, 50, 125, 32.5 ... given that a1 equals 8. So I'm looking at what is happening between 8 and 20, okay, 8 and 50, and if I look at adding, so adding would be arithmetic part of it. So 8 to 20 would be a plus 12, but then it's a plus 30. So I know it's not at a constant rate, so it can't be that, so it must be a geometric sequence. So what number could I multiply by to get 20, and then use that same number to get 50? And if you don't know, you can go backwards. 20 divided by 8. So 20 divided by 8 is 2.5. So that means then 50 divided by 20 must be the same. And just to check it, lo and behold, it is. So I'm multiplying by 2.5 each time to get that next number. So all I'm doing is multiplying. I see an adding thing, so I know it's not that. See another adding, I know it's not that. So here I have multiplication here, and I have multiplication here. Since I know I'm always multiplying by 2.5, there it is, 2.5. The reason why it's not this one is A1 equals 8. And if that was true, I'd always be multiplying by 8. And that is not true. So, choice 2. Moving on. The formula for electrical power P is P equals I squared R, where I is current and R is resistance. The formula for I in terms of P and R is, okay guys, don't run from these. These actually are usually 1 or 2 steps and you're done. So let's write it out here. And you're trying to get I by itself. So right off the bat, how do I get I by itself? I notice I have I squared times R. How can I move that R? Well, opposite of times is divide. So if I divide both sides by R, these R's cancel and I'm left with P over R equals I squared. So that's one step. The next step, how do I get rid of a squared? Take the square root. And I always tell my students that if you're unsure how to get rid of a squared, look at the calculator, okay? I see above the x squared a square root. That's the opposite, all right? So square root. So what happens is the square root cancels the squared. So I'm left with the square root of P over R equals I. So that is choice number 2. 21. We have the function f of x, q of x, and p of x shown below. So we got a graph, a table, and a quadratic there. It says when the input is 4, which functions have the same output value? So the input is my x. So here's 4 right here on this. My output value is where it hits the line. So right here, that is going to be at 3. Okay, over here, here's my input value x, so my output value is also 3. So now we gotta check one more. So we have a calculator that does the work for us. Go to my y equals, clear anything that's in there, and now I'm gonna put it in. So the function is a parenthesis x minus 1 squared and then a minus 6 second graph, get my table. So where my input is 4, here's my x, my output is 3. So they all have outputs of 3. So which one proves that? Choice 4. They all have the same output value when the input value is at 4. 22. Using the substitution method, Vito is solving the following system of equations algebraically. Which equivalent equation could Vito use? Alright, so a lot of times we solve these by elimination when we see them up and down like this. But now they want you to substitute it, which means solve the easiest one for either the x or the y. If I'm looking at my choices, I want to make sure I solve for y, so y is going to be by itself. So if I take the top one, that looks like the easiest one to do. Subtract a 3x on both sides. These cancel. Y equals negative 3x minus 4. So what that means is for the second one, anytime I see a y, I'm going to plug this in. Okay? So I see a 2x, so I'll just rewrite 2x, minus, I see a 3, now I see a y. So I'm going to plug in all this into my y, which means I need a parenthesis, negative 3x minus 4 equals negative 21. So all I'm doing is taking this and plugging it in right there. And which one shows that? it looks like it's going to be choice number 3. Okay, moving on. (23) Materials A and B decay over time. So we know we have a decay problem. The function for the amount of material A is 1,000.5 to the 2t for the amount of material, and for the amount of material B, it is BT equals 1,000.25 to the t, where t represents the time in days. On which day will the amounts of material be equal? So the only difference that I really see is the amount that's in the parentheses, because they both have the same initial, and this just has a t and this has a 2t. So a 2t acts on this parenthesis by just taking the 2 and multiplying what's in the parenthesis by itself. So a 0.5 times a 0.5 is a 0.25. So if you didn't know this part, you could plug that in your calculator. So what could go in parentheses is, for A of t, technically, 1,000 stays the same, and I could actually have a 0.25 in a parenthesis, and because I used the 2, the t is left. So I have 2 of the same equations now. These are both the same. So if they're both the same, it doesn't matter on the time, you're always going to have the same answer, no matter what you plug in for t. So, and it'll be equal every day. Choice 4. Okay, last one for part 1, and then we'll move on to part 2 in another video. It says the following conversion was done correctly. What were the final units for this conversion? So you want to cancel things out top to bottom. So if I see an hour, there's got to be an hour up top, which is right here. I see a mile on the bottom, there's a mile up top. I see a foot on the bottom and foots or feet on top. So you see how they try to trick you with the different terminology, but I know a foot is part of a feet. So what's left is inches over minutes. So that's going to be inches per minute, which is choice 4. So that's part 1. If any further questions, just let me know in class, and we'll move on to part 2 in the next video.